Hello all. Today we'll be learning about the mathematical expression a square minus b square. Its geometrical interpretation, the identity related to it, and proving the same with mathematical modeling. Before we begin, let us understand the meaning of a square. In arithmetic, it implies multiplying the quantity by itself. Here, a square is a times a. Similarly, b square is b times b. Whereas in geometry, it implies the area of a square of side a, and b square implies area of a square of side b. Now, once we know it is area of a square of side A and this is area of a square of side B, we will begin by using two squares. One is a square of side A and another is a square of side B. From a square of side A, I need to remove a square of side B. Now here, we will remove it, but we need to know what exactly do we get after this removing. After removing from a square of side B. So let us find out what exactly do we get. But before we proceed, we need to know a few dimensions here. So I turn it to the other side so that you're able to see this is original square of side A, and A. This is a square of side B. I'm superimposing it on one corner over here. Then if this is a square of side B, this is B. Total length of the pink sheet was A over here. So the remaining is A minus B. Because this is B, the opposite part from here to here will be B. Similarly, the total was A. Out of it, this part B is removed, so you're left with A minus B. This total side is A as usual, whatever we had taken up, and this is A minus B, whatever is left from A after removing B. Now, to find out a square minus b square from this pink sheet, I will remove an area equivalent to the green sheet. That means I'm going to remove this. I'm going to cut this off from here. If I cut this off from here, what exactly am I going to get is what I will see now. Now, we'll start cutting it like this. After cutting out this piece from here, which was an area equivalent to B, what are we going to get? I am going to get, this is the remaining pink sheet. I want to know how much is this. This is actually your a square minus b square, which we are dealing with. So how do we find the area of this part? The area is quite simple. Either you calculate area of this rectangle and this square and then do it. Otherwise, what exactly you are going to do? I am going to cut this part also off. If I cut this part, now there is one more method in which you can cut along the diagonal also like this, but I prefer right now like this. I'll show you along the diagonal also. So currently when I am cutting along the side, what do I get? I've already marked it so that this cutting is easy. So you're left with two pieces here, one piece like this and another one is like this. Now how do I get it? Now I know this is A minus B, so I just bring this A minus B along with it. Okay, that means we have reoriented it. We are putting it like this and this is the previous one. So in all, we are going to check what are we going to get. So to check what are we going to get, what exactly am I doing? This I know is A minus B, this side is A, this side is B, so this is a rectangle. The final one that you're having is a rectangle. Now what is the area of this rectangle? Let us check. The area of this rectangle is going to be A minus B times. This total length of the side is A plus B. So area of this rectangle is A minus B into a plus b. That means after removing from a square of side a square of side b, you are left with a rectangle whose dimensions are a plus b and a minus b. But you know area of a rectangle is length into breadth. So this is the length, this is the breadth. So together a plus b into a minus b is your a square minus b square. This is the identity and it will be used in many cases, which I will be showing you a little later. Now I told you can cut it along the diagonal also. So if I cut along the diagonal, I am talking about this piece. If I cut along the diagonal, then what do I get? I have written the dimensions, whatever we have, and we'll just check what are we going to get. So when you cut it along the diagonal like this, let us see what exactly are you left with. You will be left with these two pieces. So when you have these two pieces, just turn it on the obverse side and see what do you get. You are having over here again a rectangle of length a plus b and width a minus b. Area of this rectangle is also a plus b into a minus b. That means no matter which way you cut it, you are still getting a plus b into a minus b as the area. That means your identity a square minus b square is a plus b into a minus b. We call it an identity because no matter what values of a and b we take, the result is not going to change. This is quite a useful identity in mathematics because it's going to help us in finding many things over here for factorizing many expressions. Say an expression is of the form x square minus say 16. Then this can be written as x square minus 16 is square of 4. This is of the form a square minus b square. For me, if I compare, my a is x and b is 4. So factorization of this is going to lead me to x plus 4 into x minus 4. Once you have this, this is factorizing the expression x square minus 16. There are many other expressions which can be factored in the similar manner. This can also be helpful in a few arithmetic calculations. Now calculations of the form a square minus b square, I choose two consecutive numbers here. Say I choose 52 square minus 51 square. I need not evaluate in this case 52 square and 51 square and then do it. So what do I actually do it? This is A, this is B. Why did I only choose consecutive numbers here will be pretty clear to you. This is A, this is B, and as per my identity, I am going to get this as 52 plus 51 and 52 minus 51. Now 52 minus 51 being consecutive numbers, the difference is going to be 1, and 52 plus 51 we all know is 103. So answer is directly 103. So likewise you can find many arithmetic calculations. Thanks for watching.